One of the moon's most noticeable effects on Earth is ocean tides. Tides are the regular rise and fall of the ocean's level. In the open ocean, the high tide raises the water level about 3 feet, or 1 meter over the low tide. Along coast, tide levels vary because of coastline shape. In particular, shallow bays concentrate water into a small area and increase tide height. The world's highest tides, reaching nearly 45 feet or 15 meters, occur in the Bay of Fundy on Canada's east coast. The moon creates tides through the pull of its gravity. This pull is not enough to affect the Earth's crust much, but it's enough to cause a distinct bulge to the ocean. To appreciate the strength of gravity, feel how heavy a single bucketful of water is. Then consider that the moon lifts part of an entire ocean. The high-tide ocean bulge always stays with the moon as the moon travels around the Earth about once a month. Meanwhile, Earth rapidly rotates once a day below. From high above the North Pole, we can compare the progress of the high tide to the rotating Earth. As we'll learn later, this difference in speed has important consequences. We also can see a second ocean bulge on the backside of the Earth. This is water less affected by the moon's gravity because it is farther away from the moon. When this backside bulge passes by, it creates a second high tide for the day. So every day, ocean coasts have 2 high tides and 2 low tides. The time at which high tides occur change slightly every day. Remember, as the Earth spins, the moon moves in its orbit around Earth. So by the time this point on Earth circles around again 24 hours later, the moon has moved ahead 2 over here. High tide at this point will have to wait until the Earth catches up with the moon, roughly 50 minutes later. Long ago, scientists noticed high tide bulges don't travel exactly in line with the moon. They travel slightly ahead of it. Why? As the Earth spins around quickly below the ocean bulge, friction between the Earth and water pushes the water ahead of the moon just a little. Over long periods, this friction and the timing difference between the Earth's rapid rotation and the moon's slow orbit affects both dance partners. Astronomers calculate that every century, because of the moon's pull, Earth's rotation takes about 1/500th of a second longer. 1 billion years ago, a day on Earth was only 19 hours instead of 24. In another 1 billion years, a day will have stretched to 30 hours.